Well, hello, and welcome to another session of chemistry. Today, the topic's going to be on covalent bonding. And the main thing that I want you to take away from today is the ability to model covalent bonding through the drawing of what we call a Lewis structure, or a Lewis dot diagram. So I'm going to take you through a couple of these and show you the process. And we're going to see how the atoms share electrons in order to have a stable octet. And then I'll draw some of these as examples for you and give you the opportunity to draw a couple of them as well. Okay, so let's begin. Covalent bonding. We said before that in a covalent bond, the atoms share electrons in order to satisfy the Octet Rule. The orbitals of one atom merge with an orbital of another atom, and merging is a word that we mean there were two sort of blend together to become one. So between the two atoms, a single orbital is formed. Now this is the same orbital as what we're talking about back when we were talking about electron configurations. And orbitals is a place for electrons. It's a place for them to be. And the other important thing about an orbital is that every orbital has two electrons that go inside of it. So we're going to see that today, that this orbital is going to be formed between the two atoms, and inside of that orbital are going to be two electrons. This is what constitutes our covalent bond. All right. So remember with valence electrons that the valence electrons is where the are the electrons in the highest energy level. And of course the Octet Rule says that these atoms, in order to bond, will rearrange their valence electrons in order to achieve this stable octet. So as review, you might want to go back and check out how to determine the number of valence electrons for these elements. Why don't you take a second and see if you can draw in the number of valence electrons for each of these elements that I have listed using a Lewis dot structure. I'll give you a little time. You can press pause, and then when you come back, I'll share my answers with you. Okay, how'd you do? Here's my drawing for hydrogen. Just has one dot. Again, where the dot's placed isn't as big of an importance as how many dots. One dot to represent its one valence electron. Carbon has 4 valence electrons. Oxygen has 6. And finally, chlorine has 7. Again, if you are struggling with this and don't know how many electrons you should be drawing around there, you might want to go back and watch my video on valence electrons. So, how to draw a Lewis structure so that we can model this type of bonding. Here are some steps that I have up on the board. First, we want to find a center atom. Usually the center atom is all by itself, and usually it's the very first element. It's not always true. I'll show you some examples. Then we want to arrange the other atoms. The other atoms are going to try and spread out as far as possible from each other. It's sort of going to be arranged like a spoke that's hooking into some type of a hub in the center. So if you think of it like a wheel, it's got its axle, that's the center, and then everything else is going to be attaching to that center. This is the way most molecules are shaped. some things not to do is to try to draw things all in a line. That's not so good. Or to try to draw things that are like in circles or squares or something like that. That's not so good either. You want to try to stick with this idea that you have a center and then things are attached to the center and spread out as much as possible. Okay, so let's try one. First I have hydrogen. Hydrogen has 2 atoms of hydrogen. I can tell that by the 2 down there. It tells me I have 2 atoms of hydrogen. If I were to pick a center atom, then it would be, one of the hydrogen atoms, wouldn't it? So I'm just going to draw that here in the center. And then I've got to arrange my other atoms around it, which it only has 1 other atom. So I'll arrange it around it. There we go. Put it next to it. Third step, put in the bonds. Now this has 2 atoms that are being held together, so I'm predicting there's 1 bond between them. We show a bond by drawing in the 2 electrons in between the 2 atoms that are being bonded together. Again, I'm representing the idea that they have some type of a shared orbital between them here. And inside that orbital are the 2 electrons. And this is what holds the bond together. The positive of the nucleus, the negative of the electrons, and the positive of that nucleus is what holds all of this together. So, when you see the 2 dots, when I say draw in a covalent bond, that's what I mean right there. I mean, draw in the 2 electrons between the 2 atoms to represent those 2 electrons being shared in 1 orbital. It says fill everything up with 8 electrons except for hydrogen. Hydrogen gets 2. Hydrogen, its nearest noble gas neighbor, is helium, which only has 2 electrons. It's at the first energy level, so it only has an s orbital to work with, and that's why it only has 2 electrons. Everything else that we're going to work with is going to have 8. Finally, the last thing here is to count up the valence electrons and be sure that we have the correct number of valence electrons. We can't gain any extra or lose any valence electrons along the way. So each hydrogen here had, to begin with, brought to the party with it 1 electron each. So 1 hydrogen brought an electron, the other hydrogen brought an electron. There should be 2 electrons in my picture. Now, which electron belongs to which atom is totally irrelevant because they're sharing both of them equally now. So we don't need to say, well, this electron belongs to this hydrogen on the left and this. We don't need to worry about that. Just there are 2 electrons there. So, yes, I do have 2. So this Lewis dot model here works out fine. That's the way it should look. Let's do one with a few more electrons, huh? How about chlorine? Chlorine gas is a covalently bonded substance. You could tell because it's a gas. Remember that gases and liquids many times are covalently bonded because they have low melting points and boiling points. All right, follow the steps here. Find a center atom. Again, it's going to be one of the chlorines. Arrange the other atom around it. So I'll put the other chlorine there. Next, let's put in our bond. Remember, that's just 2 electrons that are in between the 2 atoms themselves. Next, let's fill everything up with 8 electrons. So around each of these, I'm going to put 8 electrons. In some ways, I sort of think of it as like a Venn diagram. So let me draw like a Venn diagram here. The Venn diagram is going to be looking at the electrons from each atom. And you'll see that 2 of the electrons are being shared here, while 6 of the electrons for this chlorine are not being shared. So this chlorine over here is also going to need 6 more electrons. It's not being shared. Now each of them has 8. Last step here, let's count up the valence electrons and make sure that we have the right number of electrons. Well, each chlorine started with 7 electrons apiece. So 7 plus 7, that's 14 electrons that were brought to this molecule. I can't have any more or any less than 14 electrons. Otherwise, there'd be missing or extra electrons in this molecule. How many do we have? 2, 4, 6, 8, 10, 12, 14. I do have the right number of electrons. Let's try one more, and this time let's have 2 different types of atoms. Let's pick another molecule here, ammonia. Here's that center atom. I told you it's not always there with all of them, but sometimes, many times it is. It's the one that's by itself, and it's usually the first element in the compound. And you can see here's nitrogen, it's by itself, there's only one of them, and it's the first element in the compound. So I'm going to make that the center of my molecule. And the hydrogens, I'm going to arrange around that center atom. I'll put one here, one there, and one over there. Why did I choose those 3 places? It doesn't matter, but the idea is it's going to try and spread out as far as possible. We tend to draw things on kind of like a T pattern here, 90 degrees to each other, kind of like X's and Y axes there, if you will. And sometimes we'll put things at angles, but that's kind of rare and something you'll just have to get a feel for. Next step, let's put in our bonds. Each of these hydrogens are bonded to that nitrogen, so I have to put in 2 electrons for each of the hydrogens and the nitrogens. Again, let me do like a little Venn diagram here so we can see. Here's my nitrogen now, and the electrons that are around nitrogen, and here are each of the hydrogens. And as I look around them, I see, again, the electrons being shared by the nitrogen and hydrogen. They have those in common. And then each hydrogen is only supposed to have 2 electrons, and I see that each of these do. But the nitrogen has 2, 4, 6 in its circle, so it's going to need 2 more. Finally, let's count the valence electrons. The nitrogen brought 5 electrons to this compound. And each hydrogen brought 1 more. Grand total of 8 electrons. So in my picture, I need to have 8 electrons. 2, 4, 6, 8. Good to go. All right, these next 2, I'm going to let you give your best shot at those. Again, press pause, work on them, follow the steps, and then when you've ready to go, because you've done your best, press play, and I'll show you my answers. All right, how'd you do? Did you get the right number of valence electrons in each one and everything bonded together like a spoke into the hub of a wheel? If you did, then you're probably doing all right. Here's what my picture looks like. And then each one has to have 8. Whew. And I counted a total of 32 electrons. And if you count those up, that's what you'll get. 4 for the carbon, 7 for each of the chlorines, a total of 32. And then water. Water, again, is another unusual one for the center atom. In this case, the center atom is on the end, but you'll notice it is by itself. So I'm going to put the oxygen here. And I'll put my 2 hydrogens. Ooh, say you don't like that, then by each other like that? We're going to study more about that and see why, when I talk about shapes, see why I actually put those hydrogens in that position. If you put them in a different position, let's say across from each other, no problem at this point. But later we may learn additional information that will help us out. All right, so what do you think with that? I've got my water molecule and my carbon tetrachloride molecule drawn out. There are others and some of the activities that I'll have you do, or if you're watching this and you're not part of my class, then you might want to seek out some more Lewis diagrams or electron dot diagram work from whoever you're learning from. And that concludes my session for today. Thank you.